Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I was actually discussing the physics and chemistry part of 9th standard science subject. So from this video onwards, I will be teaching the mathematics of 9th standard. So in that, the first chapter is on number systems. So to understand number systems, we can draw a particular number line. So for example, if you have a number line like this, so at the center of this number line, you will have the number 0. So starting from 0, you will have 1, 2, 3, 4, and it goes on like this. So the numbers what you have written after 0, the negative values of the same number can be written on the left hand side of the 0. That is -1, -2, -3 and -4, and it goes on like this. So you have infinite numbers on number line. Now I have just written 0, 1, 2, 3, 4 such numbers, but here always remember, excluding 0 and excluding these negative numbers, if you just take the positive numbers 1, 2, 3, 4 without any decimals, if you are just considering these full numbers, that is 1, 2, 3, 4 like this, so these numbers can be known as natural numbers. So these things I have already discussed in your 8th standard mathematics, so you can refer those videos as well. So you have natural numbers starting from 1 and it goes on till infinity. So these are natural numbers. So to this natural number set, if you are adding this 0, if you add this 0 to this natural numbers, then it becomes whole numbers. So natural numbers can be denoted as capital N, and whole numbers can be denoted as capital W, and these whole numbers contain 0, 1, 2, 3 like this, it goes on. So that means in whole number you have all the natural numbers and you have one extra number, that is 0. Similarly, if you are considering the negative part of this natural numbers on the other side, then you have like it starts from infinity, minus infinity, and it comes to 0, that is from minus infinity to -4, -3, -2, -1, 0, 1, 2, 3, 4, and it goes to plus infinity. So that means here this entire system can be known as integers. So even in integers, you don't have any kind of decimal numbers. Like for example, you don't have 4.3 or you don't have -3.6. These kind of numbers are not possible in integers. You have to take the full number and negative part of these natural numbers, including 0, is under integers. So you can call this as capital I. Similarly, you have rational numbers as well. So what do you mean by rational numbers? I have recorded video on rational numbers in 8th standard mathematics. You can go to the playlists and refer those videos as well in your 8th standard. So rational numbers can be denoted as the capital letter Q. So always remember, rational numbers can be expressed in the form of P by Q, where P and Q belongs to the integers and Q is not equal to 0, because if this particular denominator becomes 0, then that particular number is not defined, because you cannot divide a particular number with 0. So that means you have to divide that particular number 0 times, which doesn't make any sense. So that's why we don't know what is the value if you are dividing a particular number with 0. So that's why any number divided by 0 is always known as not defined. For example, 1 divided by 0 is a not defined number, because we don't know what will be the answer if we divide 1 with 0. So this cannot be a rational number. So always remember, Q should not be 0, that is in the denominator 0 should not be there, and both P and Q should belong to the integer set. So this is about rational numbers. So before going into irrational numbers, we will explore more about these rational numbers. Here you have one example in this particular chapter. So coming to the first question in this example 1.1, here they have given every whole number is a natural number. So here in example 1.1, you have every whole number is a natural number. So is this statement true or false? So always remember, every whole number is not a natural number, because in whole number you have one extra number other than natural numbers, that is 0, and 0 cannot be a natural number. So 0 is not a natural number. So hence the answer for this particular first question is false. Here every integer, that is, I'll just write I, is a rational number. So what I told about rational number is, you can express a number in form of p by q, where p and q belongs to the set of integers and q is not equal to 0. So this is the condition for rational number. Here if you are considering any integer, for example if you are considering -2, or for example if you are considering 5, or if you are considering -3, all these integers can be expressed as -2 by 1, 5 by 1, -3 by 1. So here 5 is an integer, 1 is an integer, -2 is an integer, 1 is an integer, -3 is an integer, 1 is an integer. So for rational numbers, p and q should be integers. So you have integers only in both numerator and denominator. And also you can see q should not be equal to 0. In all these three cases, q is not equal to 0. So you have a value in the denominator, which is not equal to 0. That means here every integer can be expressed as a rational number. So that's why the answer for this second question is true. So in this example 1, if we come to the third statement, here they have given every rational number is an integer. So here every rational number is an integer. So this is what they have given as the third statement. Here for a rational number, always the condition is a particular number if it is expressed in p by q form, where p and q are integers, and if q is not equal to 0, then you can call that number as a rational number. So for example 2 by 3 is an example for rational number, because here 2 is also an integer, 3 is also an integer, and you are expressing this as p by q form, and here q is equal to 3, which is not equal to 0. So 2 by 3 is a rational number, but if you calculate the value for 2 by 3, so somewhere around you will get 0.666, and it goes on like this. So that means here you are getting in decimals. So that means 0.666 is not included in the set of integers. So that means every rational number cannot be an integer. So third statement is false. So coming to example 2, here they have given 1 and 2, and you have to write the rational numbers between 1 and 2. You have to give 5 rational numbers in between 1 and 2. So the easiest method to find rational numbers is, you can express 1 as 6 by 6. So why I am taking 6 in the denominator is because you want 5 numbers, at least 5 numbers. So one extra number I am putting in the denominator, that is 6. And if you want to get the 1, then you have to put 6 in the numerator as well, because 6 by 6 is equal to 1. So now you want 2. So again in the denominator I want 6. So what number should be there in the numerator in order to get to 12? Because 12 by 6 will give you 2. So numbers between 6 by 6 and 12 by 6 can be the example for rational numbers in between 1 and 2. So that means here you can write this as 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6. So that means you got 5 rational numbers in between 1 and 2. So this is one method where you can find rational numbers between any two natural numbers or integers. And one more thing you should remember, these are the not only 5 numbers which lies 5 rational numbers which lies in between 1 and 2. Always remember, between 1 and 2 there will be infinite number of rational numbers. So always remember, between 1 and 2 there will be infinite number of rational numbers. So that means there will be so many rational numbers present in between 1 and 2. For example, in the place of 6, if I take 8, then 1 is equal to 8 by 8 and 2 is equal to 16 by 8. So again here you can see 9 by 8, you can take 10 by 8, you can take 11 by 8, you can take 12 by 8, you can take 13 by 8, you can take, so 14 by 8, 15 by 8. So that means these many rational numbers are also there in between 1 and 2. So for example, if I take 1 is equal to 9 by 9 and if I take 2 is equal to 18 by 9, then again 10 by 9, 11 by 9, 12 by 9, like this it goes on till 17 by 9. So these rational numbers also exist in between 1 and 2. Similarly, if I take 10 in the denominator, that is 1 is equal to 10 by 10 and 2 is equal to 20 by 10. Again 11 by 10, 12 by 10, 13 by 10, all these numbers lie in between 1 and 2. So like this, if you go on doing this, you will find infinitely many numbers in between 1 and 2. But in the question they have asked only 5 numbers. So you can write any 5 rational numbers between 1 and 2. So always remember, the rational numbers which you write should not be less than 1 and it should not be greater than 2. It should be in between 1 and 2 as per the question. So now based on all these ideas, we will just move on to the first exercise in this particular chapter. So that is exercise 1.1. So in exercise 1.1, coming to the first question, here you have, is 0 a rational number? Can you write it in the form of p by q, where p and q are integers and q is not equal to 0. So that means here p by q is a rational number where p and q should belong to the set of integers and also q should not be equal to 0. And here they are asking whether 0 is a rational number. So always remember, the denominator value should not be equal to 0, but in numerator 0 can be there. So that means 0 can be written as 0 by 1. So here both 0 and 1 belongs to the integer set, because 0 is also an integer, 1 is also an integer, and here q is equal to 1. So that means in the denominator we are taking 1 which is not equal to 0. So that means 0 can be expressed as 0 by 1. So answer for this first question is yes, 0 is an rational number. So coming to the second question, here you have to find the rational numbers in between 3 and 4. Similar to the example to what you have done between 1 and 2, the same thing you have to do here in between 3 and 4. So because we want 6 rational numbers, we will write 7 in the denominator. And if you write 7 in the denominator, then what should be there in the numerator, so that you will get the answer as 3. So 21 should be there in the numerator, because 21 divided by 7 is 3. Similarly, if you are writing 7 in the denominator for 4, then what should be there in the numerator? 28 should be there in the numerator, because 28 by 7 is 4. So that means here 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7. So all these rational numbers are there in between 3 and 4, and of course there are infinitely more rational numbers in between 3 and 4 as well. So coming to the third question, here you have to find 5 rational numbers in between 3 by 5 and 4 by 5. So in order to do that, you can just multiply 6 to both numerator and denominator for 3 by 5. So when you multiply 6 to both numerator and denominator, so 6 into 3 is 18, 5 into 6 is 30. Similarly, so 4 also you can multiply with 6, 5 also you can multiply with 6. So 6 4s are 24, 6 5s are 30. So here also 6 5s are 30. 6 into 3 is 18. So in between 18 by 30 and 24 by 30, you can write 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30. So 5 numbers you have got, and there are more numbers as well in between 3 by 5 and 4 by 5. Always remember there are infinite numbers between 3 by 5 and 4 by 5. That is infinite rational numbers in between 3 by 5 and 4 by 5. So now we have got these 5 rational numbers in between 3 by 5 and 4 by 5. So coming to the fourth question, here you have to state true or false for these statements which are given in the fourth question. Coming to the first question in fourth question, here every natural number is a whole number. So here they have given every natural number is a whole number. So here always remember natural numbers contain 1, 2, 3 like this. The full numbers starting from 1 till infinity it contains in natural numbers, and always remember in whole numbers contains all natural numbers and it contains an extra number that is 0. So that means 0, 1, 2, 3 and it goes on like this. So that means here they are asking every natural number is a whole number. Because whole number is already containing natural numbers, so every natural number can be a whole number. So the answer for this first question is true. Coming to the second statement in this fourth question, here they have given every integer is a whole number. It is not true, because in integer you have -2, -3, -4, such kind of negative numbers are also there, which is not there in a whole number. So that's why every integer is not a whole number. So false is the answer for this second statement. So coming to the third statement in this fourth question, here every rational number, so every rational number is a whole number. So this is also false, because here in rational number you have 1 by 2, you have 4 by 5. So all these rational numbers are not whole numbers. So that's why every rational number is not a whole number, and that's why the answer for this third statement is false. So this is all there in this particular video. I have taught the examples and exercise 1.1 in this particular first chapter. The irrational numbers which is there after this particular concept, and that I'll be teaching in the next video. Like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.